and welcome to North Valley Precision Planting. I'm John Fox, and today we're going to be talking about row unit maintenance. We're going to be discussing the top 10 most common wear points on a row unit, starting at the front with our parallel arms and our W bracket, working through our DownForce system, talking about our meters, our seed tubes, our gauge wheels and gauge wheel arms, our depth control, all the way back to our closing system. We're going to be discussing common wear points and some of the ways that we can correct those issues, whether it be a replacement part or some setup. We're going to start back here at what we commonly call the W bracket. This is the mounting plate that mounts our row unit to our toolbar. Of course, we're looking at it here on the stand, but what we want to do is a visual inspection. We want to look at our fasteners. On most planters, we have a U-bolt that will go around the frame. In this one, we've got a welded plate to an angle iron on the side, so we want to make sure that we look at all the welds that fasten those two pieces together. Just check them visually for any sort of cracking or any unusual wear. Take a look at our parallel arms up here, do a visual on the fasteners. Basically just a nice visual to see if there's any sort of obvious wear, any cracking, any sort of concerns at all. So next we're going to move on down and we're going to look at our parallel arms. We want to take a look at the parallel arms for any sort of wear similar to we did with our W bracket. We want to look at all the different fasteners here. One of the things that we use commonly is we tend to just pick up the tail end of the row unit. So we just want to check for row unit wear, slop in this area up here, also in the top corners and then on our bottom cast parallel arm as well. The amount of wear that we're seeing here is very common on the John Deere row units. There's a number of different options available in the market to try and solve that problem, but we want to just inspect that and see if there's an excessive amount of play, make sure that the hardware is in good order. So another good option for you if you have the tool at home is to use an engine crane or a cherry picker and just lift up the entire row unit. When you lift that up, you remove all the weight from all the pivot pin areas here, all the parallel arms. And it gives you a better idea of what the slop looks like on this lower parallel arm. So there's a number of different options in these parallel arms to repair them. One of the more common options that we've discovered here and began using, I don't know if we want to get a close-up here, but we use a replaceable bushing that gets inserted into the parallel arm. Use a reaming bit and you oversize that hole, getting rid of the hardened steel bushing, and this becomes our new wear surface. We've begun using these here for about the last 18 months, and we've had tremendous luck with them. They're a very effective way to remove all of the play and the movement in our parallel arms. And that's important because, you know, with the different types of terrain, field conditions, how rough that field is that you're going across, we're going to encounter a lot of row unit movement, and row unit movement can impact our metering performance. You know, you may have brought your meters to me and I may have tested them on the stand, but you know, poor ride quality due to a lot of chatter on the row unit can certainly impact what sort of spacing we're actually going to see in the ground. So while we're up here and we're looking at our parallel arms and our W bracket, our mounting plates, we want to do an inspection on our DownForce system. The one that we have in front of us is our DeltaForce, the hydraulic cylinder. But you may have springs, the earlier style side springs for the parallel arms. You may have a heavy duty double spring assembly. You may have a pneumatic airbag. But in any example, we want to just visually inspect them. We want to inspect the springs if that's what you have for wear or for broken springs. The eyelets, you know, have a tendency to wear. If we've got a pneumatic system, we want to inspect the airbag for cuts or damage, possible leaks. We'd also like to inspect, you know, any of the air lines that are supplying the pneumatic system, the airbag. We want to look at them for cracks or for leaks. You know, you could use a little spray container with some soapy water to check for leaks if you've got the system pressurized. If you have a DeltaForce system like that, we want to give a good visual inspection of the hoses leading to the cylinders from one row to the next. We want to look at them for leaks, the hoses for any sort of cracking or chafing, any sort of problems visually that you can see. We'd also like to inspect the mounting points, the pins on the top and bottom bushings for any sort of play or some wear. We want to look at the hardware that's fastening, in this example for our DeltaForce system, the hardware that's fastening our lower mounting bracket. We want to just make sure that that hardware is in place and it's nice and tight. Of course, this is just our display model, so nothing's been fastened tight here. But that's one of the things that you want to look at. You know, we have an electric drive meter here, so we don't have any chains. But if you have an earlier model planter and you're still running a chain drive, we want to inspect the drive shafts that would reside in this area, a hex drive shaft with the sprocket and chain assembly that would come down and drive our original meter assembly. We just want to inspect the sprockets visually, make sure that they don't have any funny wear, anything unusual. We want to inspect the chains, make sure that they're not stiff and frozen. You know, those type of examples can cause us to have metering problems that aren't actually related to our meters.